Hi, I'm Chris from Pro-M Racing. Today we're going to talk about the proper way to design a fuel supply system. Let's start with the fuel tank. The fuel tank should be properly baffled to keep a supply of fuel at the fuel pickup tube. There are a lot of production cars out there with properly baffled gas tanks, so if you can use one, that's a good and inexpensive option. Let's say, for example, you're putting a fuel injection system into a 1985 Monte Carlo. That car was originally equipped with a carburetor, so the stock tank isn't much good. However, the Monte Carlo started being offered with EFI in about 1987, so you could go to the parts store and for about $120 buy a new gas tank that will fit right in the 1985 with the proper baffling. If you're building a custom car, try to engineer the build around a baffled production tank, or you could always go the expensive route and have a custom tank built. We also offer a universal in-tank fuel pump conversion kit that can be installed in many tanks and includes a baffle. Other options are a sump that can be welded to the bottom of most any tank, or even simply running the stock unbaffled tank and keeping the fuel level up so the pickup won't get uncovered. Next is the fuel pump. If your engine's horsepower rating is 650 horse or less, and there's a tank available for your car that will accept an in-tank pump, then I'd recommend you stick with an in-tank pump with a high enough flow rate to support your engine's rated horsepower. If you're going to make more than 650 horsepower, you'll need to use an external pump since there is not an internal pump available with a high enough flow rate. Again, the pump needs to flow enough fuel to support the engine's rated horsepower, but don't go too far overboard. We're going to discuss the pitfalls of a very high volume fuel pump a bit later. Some guidelines on fuel pump selection. An 88 liter per hour internal pump is good for up to 250 flywheel horsepower. 190 liter per hour internal pump is good for up to 540 horsepower. 255 liter per hour internal pump is good for up to 650 flywheel horsepower. Our 325 liter per hour PHP 325 pump is good for up to 900 flywheel horsepower. Our 110 gallon per hour Mallory 5110 FI pump is good for up to 850 flywheel horsepower. And the 135 gallon per hour Aeromotive A1000 is good for up to 1000 flywheel horsepower. The fuel pickup tube needs to be sized large enough to support the fuel pump's flow rate. 3/8 is good for up to a 255 liter per hour pump. 1/2 inch would be good for the PHP 325 and the 110 gallon per hour Mallory. The Aeromotive A1000 is going to need a 5/8 pickup tube. In-tank pumps will come with a sock attached to the bottom. You must use the sock. If using an external pump and a pickup tube, do not put a sock on the tube. It will not flow enough fuel to support the pump. The fuel lines also need to be sized large enough to support that volume of fuel. For up to a 255 liter per hour internal, I'd use 3/8 line throughout the entire system. For the PHP 325 and the Mallory 110 gallon per hour, use 1/2 inch from the tank to the pump and 3/8 for the rest. The Aeromotive A1000 will need to be 5/8 from the tank to the pump and 1/2 inch for the rest. The fuel filters need to flow enough fuel to support the fuel pump's flow rating. In addition, if you're going to use a pre-filter, it must not create any restriction to the pump. These filters will have a high micron rating and are typically just a piece of screen in a canister, the idea being to protect the pump from large particles. Again, there must be no restriction between the tank and the pump. Furthermore, external fuel pumps must be mounted even with, or preferably even below, the bottom of the tank. There must be a fairly large filter in the fuel line between the pump and the engine. The micron rating must be 10 or smaller. These filters are very fine, so they must have a very large amount of surface area inside to maintain a high flow rate, which is why they tend to be pretty large. Make sure the flow rate of the filter exceeds the flow rate of the fuel pump. The fuel system should be plumbed as follows. Fuel pickup tube to the pre-filter. Pre-filter to the pump. Pump to the 10 micron filter. 10 micron filter to the fuel rail. Connect the front of the fuel rails together. Fuel rail to the side port on the regulator. Bottom of the regulator to the return line to the tank. It's important to have the fuel return tube transition all the way down to the bottom of the gas tank. The best analogy for this would be a garden hose and a bucket of water. If you fill a bucket of water with a garden hose and hold the garden hose above the bucket, you'll see the water coming out of the hose landing in the water in the bucket aerates the water in the bucket. Fuel does this same thing, but much worse. If you take the garden hose and put it in the water in the bucket, you'll see that the water transitions into the bucket and the water is not aerated. You should also make sure that the fuel return tube dumps into the baffled area. This keeps a constant supply of fuel around the fuel pump. We should also discuss the potential problems associated with running large volume fuel pumps with small gas tanks and the symptoms of running low on fuel with a high volume pump. The large volume of fuel re-entering the gas tank where there is little fuel in the tank will cause aeration of the fuel. Furthermore, since it's the same small amount of fuel circulating through the fuel system over and over again, the fuel will tend to get warmed up by running over the engine and start to boil in the tank, further aerating the fuel. This will happen even with a properly designed system. The solution is simple. Run a fuel pump that flows enough fuel to support your horsepower, but don't go overboard. And if you're running a very high volume fuel pump, keep the level of fuel in the tank relatively high. The wiring needs to be sufficient for the current draw of the fuel pump. For example, if you're running an in-tank pump on a Fox body Mustang, the factory wiring is fine. Larger external fuel pumps will require heavier wiring. We offer a kit for the Fox body that makes this task a snap. It'll also work well in other cars. Your fuel pressure regulator should have a vacuum port on the side and should be vacuum boost referenced. The reason for this is to maintain a constant delta pressure in the fuel injectors. The vacuum in the intake manifold acts on the fuel injectors, and the fuel pressure regulator must adjust the pressure in the fuel rail to compensate for this. For instance, if your base pressure is 40 psi and you have 18 inches of manifold vacuum, that 18 inches of manifold vacuum is equivalent to 9 pounds of negative pressure in the intake manifold below the injectors. So if your fuel pressure were to stay at 40 psi, you'd actually have 49 pounds of fuel pressure in the fuel injectors. The fuel pressure regulator will reduce the fuel pressure in the fuel rail by half of the manifold vacuum, therefore maintaining that constant 40 psi delta pressure in the fuel injectors. The fuel pressure regulator should also increase fuel pressure 1 pound of pressure for every 1 pound of boost. For instance, if you were making 10 pounds of boost, you'd have 10 pounds of pressure in the intake manifold, which means you would need 50 pounds of pressure in the fuel rail. The difference, of course, still being 40. One of the most common tech support phone calls we get is from people who are having trouble cutting their stainless braided hose and having trouble installing the fittings. The best way to cut the stainless hose is with a regular old masonry chisel that you can get at any hardware store, and a good sized hammer, and a piece of scrap aluminum. Just put the chisel wherever you want to cut it, give it a couple of good hits. That's it. To install the fitting, just take the socket off, mount it in the vise, put a little oil on it, and a little on the hose. I'm going to take a pair of pliers and round this back up again. It gets squished from hitting it with the chisel. Just put it in the end of the fitting, twist it in there until it's bottomed out, turn it around. A little more oil. Get it started by hand. And once you can feel the threads engaging, you want to hold the hose in place with one hand while you screw the fitting in with the other one, so the hose doesn't push out. That's it. And that does it for this segment. Be sure to check out our website at proamracing.com for more helpful videos. Until next time, I'm Chris Richards for Pro Am Racing.